Alright, welcome back. And last time we were working on the type checker, and today we'll continue with that. So all that we managed to do last time was check if we redefine data types and if we redefine functions. And this time I want to go ahead and try to find and do the inference on the body of the functions and check if the typings are correct, right? So let's see an example maybe of hello world, right? So how the stack language looks like. First we need to import standard library, then we have the main function, and for to define a function you use the func keyword, right? Then we have the input arguments, or I guess the types only in these parentheses, but we don't use them yet. And the reason why is because these are going to be used by the type checker, and we are at that stage right now, so we'll start to use these things, and these are the types, right? So input types and output types. Maybe this one is not the best example because it's really simple, but if we check fizzbuzz, for instance, we have this I mean, they're all simple, but yeah. I mean, I have even this test data, which I don't even use, but maybe let's see rule 110, because this one was much bigger, and maybe it's gonna make more sense if we check out this one, for instance. We have a pointer and a range, and then we return 3 integers, right? So this is the type of this function. And what I'm planning to do today is make sure that all of these instructions from inside of the function body actually modify the stack by taking this thing as an input and producing this on the stack. So that's what I want to do today. Basically go through each of these comments and generate them in the compiler, right? So make the compiler do this work for us, right? So yeah, but it's gonna be interesting because memory here, it's the basically in C it's a pointer, right? So it's gonna be a void pointer, and we don't really know if it's a int pointer, some data structure pointer like a range pointer. It's not really clear, right? So it's just pointer. And I was thinking maybe in the future, but we'll see at what point we can actually have that, is to parameterize types by like putting an a here or int, right? So if we go to standard library right now, memory, we don't even define it, I guess. I said that let's not worry about memory for now, and let's only do the basic types, and we'll see how we can think about pointers. So is it gonna be like memory a extra, like we'll have this extra generic type on data? I guess it makes sense. Probably that's how we can solve it. But yeah, because you can also see here tup2, for instance, it has two arguments that are type A, like any type B, some other type, and it produces this on the stack. So yeah, right. But these ones aren't that difficult because it's like A, it's, you just make sure A appears here as well. So yeah, you define this type in the context of this function basically, but we'll see how we can do that. Yeah, probably it's going to be much easier for functions like plus, but I mean plus, like these external functions will assume that they are correct, so we don't do anything about them, right? We'll assume that, okay, this function takes in two ints and produces one int. If it doesn't, then it's a problem with whoever implemented the compiler, right? And they were wrong. I mean me. But when you use the plus inside of another function, we'll have to make sure that it actually consumes two integers and it produces one integer. So yeah, like those are how do you do that in math? You have like theorems and some other thing like axioms. Yeah, anyway, you get the point. We have some things that are true for sure, and we have to prove that these functions also are true. So it's like induction. I don't know, I'm not good at math, so yeah. But let's go to the compiler and let's try to implement those things. So this one was checking if data exists. I'm planning to add the constructor and the field getters as functions. So, but that's only for data that is not external, right? So let's make actually, oh, let's go to tests and we have some type check, right? Well, I mean, I guess we can do an example and just work with that example. So 04 type check.sl and let's import stdlib and define main. So let's have, first of all, let's do it like this. So we catch an error. We are missing the 0, right? Let's see how we can do that. So let's go to main.c. All right, so here we go through all the functions, right? And we define them. So as I said, these are the define steps. So we define all the data types, then we define all the functions in our context. Add arguments and return types. So I think cfunc is a data structure, right? Cfunc was a data, yeah. It has arguments and returns. So but cfunc is not initialized. So cfunc, does it have an initialize? It doesn't. So I would make a function static void stack context func init pointer func, and I'm just gonna say func name probably is like 0 ds dynamic array init func arguments, and here it's size of ds string size, right? And the other one, I mean, it's equal to 0, right? It doesn't work anyway. And returns. So we just initialize these dynamic arrays that we free here. So anyway, where is the thingy here? So probably I would say here like stack context func init cfunc, right? And that way we can add return types and argument types. So yeah, as I said here, we cannot check if the types exist because the types can be generic. So like A, B, C, you know, you can put anything there. So we cannot really check that. We just have to assume that, okay, that's some kind of type, and we just have to make sure that the types match, right, inside of the function. So I guess what I could do is we have some functions ds dynamic array copy, but copy is not the best because copy also allocates. So I guess copy is an unfortunate word. It should have been clone to also allocate, and I would use copy to, do I actually use ds dynamic array copy? I don't really use it, so might as well just call it clone, right? And let's have dynamic array copy. So for the copy, I mean, it's a bit unfortunate, right? Could leave it as copy, but see here it overrides the items, which kind of makes sense, but I wished I only did mem copy, you know, unless the size wasn't enough, you would do realloc. So maybe that's a good point. Maybe I want to do realloc here. Realloc, it takes in allocator, pointer, old size and new size. So it would be da ds, yeah, da allocator. What the fuck? The allocator, the pointer, so copy items, da capacity, so it's old size, which means it's copy capacity times the item size, and the new capacity is this one. So maybe like this it makes sense, because we just realloc, right? So realloc takes in the allocator, pointer, old size and new size, right? So old size is going to be copy capacity times the item size. So if you have like 0 capacity, then it reallocs it, but it's gonna be copy like overwriting, right? So I'm gonna use realloc, because realloc also frees the old items if there are any, right? So it makes sense to use realloc, honestly, inside of copy. So I'm gonna use copy, and copy takes in the target and the target and the end. Oh, but yeah, that's the problem. We don't even need to use copy. We can just do a for loop, because the types are different. I mean, my bad. I is less than func args dot count I plus plus, and then we have, so args is actually a stack AST node. Stack AST node arg, right? We do dynamic array get func args I arg, but I mean that change is still good. So this one is unreachable if it fails. We can just check it like that. And what can we do then is ds, and this one is ds expect dynamic array append. We try to append in cfunc dot args argument dot value, which is a string slice, but for ds error out of memory, but for that we need to put the address. So we just copy the string slice inside of there. Okay, We're not yet sure if this is gonna work, right? Because we just put a string slice, but like I'm not sure where the error should be displayed in case we have a failure in the type checker. So that's gonna be interesting. Maybe on the first node that produces a failure or something, but you cannot really know because you can have like any path from args to reds, like from start to finish. You can take any path that generates that, so that's a bit strange. So we have reds, which is also stack node. Perfect, so we don't even need to change that much. We just need to change the array and maybe the name of the field, right? So just like that. So we added the inputs and outputs basically of the function, right? And we also added to the context. So now that we defined all the data types, well, we haven't defined yet these, but we'll get to that in a bit. So yeah, we defined all the functions. So how are we gonna implement this inference step? Well, luckily for us, well, it's not that lucky if I'm thinking about it. So we go through functions. Right, and if I'm being honest, no, because I want to define functions first. Right, I want to define the functions first with their types. But yeah, I mean, if I think about it, I also kind of want to point all the functions that are used in the body of the function to this kind of constructions. So to stack context func, right? I want to take, and well, it's like stack context functions or some other expressions, but yeah, in a way I wanted to annotate the words, but that's not really needed. We can just search the array for that because we have the function name, right? So we can just search, which is gonna be slow, but who cares? So I would make another for loop over the program functions, right? And again, we need to take, so I cannot make it on C functions. C functions are just to define. Like that's a bit weird, but whatever. Right, we just check that the function doesn't exist twice. So then it's interesting. Do we even need this stuff? Huh. I mean, I guess this is not really needed, but let's just keep it like that for now. So because we can have inside of where is it? Inside of context funcs, we'll also add the field getters. So that's mainly the reason why we need that, right? So we go through all the functions of the program and we need to get let me just go ahead and copy some of these. So we need this this func. We need to get that function, right? And here we have something like if func dot, if it's extern, then we just continue, because we cannot do anything about external functions. We just assume they are true. As I said, if you look at stdlib, I said that we just assume that these are correct. We just assume that, right? So what can we do in case they are not external? Well, we have to do a for loop over the body, right? We have to do a for loop over the body. But at this stage we have the inputs in args, and we also have the outputs in reds, right? So we could have a dynamic array for the types of these things, right? We have dynamic array for these types, and yes, yeah, let's see. So we have the dynamic arrays of the arguments, and we need to match the dynamic array of the return types. That's kind of my idea. We'll see how well it works, and then each function that we get from the body, we have to search it in the context of functions, and the context of function has some inputs and some outputs. Yeah. Should I maybe make a function that searches for a function here? I mean, why not? So I can have static int, let's say, static int stack context function find or function get, and it's gonna be stack context and string slice name of the function. So let's do result is equal to 0 and defer return result, just to have some stuff. Okay, so let's do a for loop over the functions. So funcs count. I'm not really gonna use hash maps, to be honest. I feel like if we use only arrays, it's gonna make some things simpler to understand, and maybe even simpler to, you know, implement in other languages. I'm not gonna do any spoilers, but I guess. So ds unreachable. Oh, I mean, yeah. So I'm gonna do stack context function item. So we just did dynamic array get from the context funcs index I and item. Right, so that's that. And if ds string slice equals between, I guess, item name and name, then it means that we found the function. So I'm gonna put here stack context function. It's a pointer to a func. So here I could just say that func is equal to item, I guess, yeah, and return differ 0, and in case we didn't find it, we return differ 1, right, like an error. Yeah, I mean, that looks good. Let me just remove that. So if we go down here, right, we can just say something like, probably it's going to be unreachable to not find it, but stack context function func get. I mean, could be an error. Like if you don't find this function, it means it wasn't defined. So we'll see what we can print. So here I'm gonna do context, name, and function. So context, function, wait, why do I need that? I just need to check the body though, but you get the point. We'll have something like that. So for unsigned int j, we should iterate the func body j++, and now at this point we need to search for whatever it's inside. Oh, body count. Yeah, so what's inside of the, it's expressions, right? We have stack st expression, stack st expr expression. But I mean, expressions can be more things. We can have number, boolean string, name, and condition. So each one is gonna be done differently. But I think the dynamic array args is an interesting idea. And even reds. Like these are some interesting ideas. But kind of already have them. Don't really want to, you know, break them. So I'm just gonna make copies of them, right? And then just use them as it is. So here, for example, let's define them at the beginning, and I'm gonna do something like ds dynamic array copy, and yeah, I guess copy makes sense now. So functions args, we make a copy of the arguments, and we make a copy of the reds. I mean, not really needed for returns, but for the arguments maybe it makes sense. So what can we do next? Well, we need to make sure that we make a switch on expression kind, and let's populate the switch. So we have a few cases. If we get a number, we just need to add integer, the type of integer, to the arguments, right? So we push, well, maybe it's a better name if we call this thing stack, right? And let's allocate only stack. So here we put arguments, obviously, and we put all of our arguments to the stack. And maybe to make it even more obvious what happens, let's do dynamic array append many. Although it looks better with copy. It looks a bit better. So we just put all the arguments on the stack, right? So if we find a number, we have to put on the stack another int. So I'm just gonna do ds dynamic array append stack, and here it should be a string slice if I'm not wrong about it. So I'm gonna do string slice stack data int. and then we can break. So that's what we need. Yeah, I don't have anyway. So we just append this thing onto the stack. Right, so args is, why can't I? It's something was, so function, it's stack st node though. But it should be stack st func. Right, we have func. Well, yeah, I guess I should have used this stack context get though. At least here after, okay, so it was needed actually. Function dot name, and then we need the context function. So stack context func cfunc. So I can pass here cfunc. I guess it's value, yeah. So I'm gonna say this one is unreachable because like we just added the function here in the funcs, so it should exist. But if it's external, we don't care about it for step. But if it exists, then what we have to do is to copy the cfunc arguments into the stack. So we copy the string slices. That's what I wanted to do. So this one is ds string slice, right? It has string slices, so that's why I needed this thing. And copy, somehow it can fail, so let's say ds error out of memory. Right, so we push all of our arguments on the stack, and by that I mean the types of the arguments, right? And then in case we find a number, we just push another number. Let me just also ds expect. All right, so we can just continue like that. Right, if we find a boolean, we just push a boolean. If we find a string, we just push a string. If we find a name, okay, we don't push a name. Oh, chill, we don't push a name. We push, actually, I guess here we need to make some checks, right? We need to make some checks. So name will always be a function, so name is a function basically. And what we need to do is take the last name.args arguments from the stack, arguments from stack, and we need to make sure that they are the same as the args of the name, right? We need to make sure that they are the same. And if they are not the same, then we are cooked, we can show an error. And then if that works, we push reds on the stack. So see, we don't really go recursively into this function and check it or something. We assume it works. So here we assume the function works as expected, right? And we just make sure that it works as expected also in the current context. So we make, yeah, it's also like induction step. We assume it works by itself, and now we make sure that it works in the current context, right? So we make sure that, okay, this function like it works. So let's imagine it works, but does it work also with the current function or does it not? So that's what we do here. And I guess for our current example, so we have 0, 4. It's not really needed yet, this entire logic, so we can skip it. And it's going to be interesting for conditions. I think just to make life easier, I will assume that I want same outputs and inputs for if and else case. So I'm not going to allow unbalanced, types on if and else. You need to have the same types, and that's that. I mean, for the condition, we actually have to go into the expressions, but let's just do these things for now. Let's not use functions yet. So I'm gonna do something like the Hispanic not implemented yet, and as well for the conditional. So what can we do afterwards? We need to make sure that the returns are the same. That's what we need to do. So at the end of the execution of this for loop, we need to make sure that the stack is equal to the returns. So see, yeah, and that's the problem that I mentioned. We cannot really say which instruction introduced the bug. So that's something I might want to think about, because but I mean, it's still useful to say, okay, this is what we expected and this is what we got. So yeah, let's do that first. So we need to make a for loop. Okay, so let me just put some comments just to have an idea. So we have stack, which is the current types on the stack, right? So this would be what we have on the stack. And we have reds, which is cfunc.reds, is the current, or I guess the types we expect on the stack, right? So maybe the first check would be if stack.count is not equal to cfunc reds.count. I could make a pretty cool function. So how do I show errors in here? Okay, I can have a big if, like a big check like this one. So I'm gonna do something like, oh, maybe I'm gonna do something like this one. A static bool stack type checker is stack equal reds, right? Something like that. So then stack context, because we need a context, and then we need this dynamic array stack and this dynamic array reds, and these things are gonna be ds string slices, right? Both of them. All right, so what can we do? Well, first of all, is the stack.count is different than reds.count. Then we return false. They are not the same, right? And then we can do a for loop. Unsigned int I is equal to 0, I is less than stack.count, I plus plus. And then we have a stack ds string slice stack slice and a red slice or whatever. And now we annex unreachable ds dynamic array get from the stack index I into stack slice, right? And also into red slice. Let's return true at the end. So what's the next step here? Well, if ds string slice equals, and I'm gonna do not equals obviously, between stack slice and red slice, we return false. And I guess it wants something like that. Okay, that makes sense. And I guess how do we show the error? Let's implement another function just like this one. And I'm gonna say is redefined error stack is not equal to reds or something. I don't know, it's a weird name, but let me just put it like, oh shit, nah. Okay, anyway, let's have a different function. So how are we gonna do this one? Well, we need to say something like a function has something wrong with the types, and I mean the problem is making the call to this error. It's like making the call to this error f, because the error f has some construction, so I should probably just write it from scratch, right? Which kind of sucks, but at the same time I don't really want to build strings, and I mean, why not? After all, we could just build a nice error and call that thing, so why not? Let's make a for loop like this one in here, and I can have, okay, whatever, I can just move it like that. Anyway, like a string builder sb ds string builder init, and then we can do stuff like, okay, we get these, or I guess I'm gonna do ds string builder append expected sb expected So how is the error gonna look like? Maybe let's think about that. So function and then the function name, maybe, right? Maybe the function name has non-matching output, and then we can say expected, and here it's the returns but got, and this is the stack. Has non-matching return, expected this but got this. Okay, so it means I also need a function name here. So maybe ds ds string slice, right? Although usually I just put like the node. So I'm gonna do the node as well. So it's gonna be stack st node func. So the node itself, right? So I'm gonna do function percentage s has non-matching return expected, and we are gonna put them in parentheses. So I'm gonna stop there. Function value len, function value str. So that's gonna be ds expect ds error out of memory. So this is how we append the first step of the error. And then we have to make two for loops, actually, one for the expected and one for the got. So we go from 0 to function rets. I guess we already have the rets, so I'm gonna do rets. Right, rets count, and we have a slice. So we just take the slice and we just put the thing into there. So I'm gonna do something like let me just copy it. I had a brain fart. So I'm just gonna copy this thing and I'm just gonna put something like this, and then slice dot length and slice dot str. Right, so that's that. And then if I is equal, I guess if I is less than res.count minus 1, I'm doing something similar, but I add a comma. right? I just add a comma, and otherwise, I mean, at the end of the execution, I just add the closing parentheses and then but got, open parentheses, right? And then we have the same for loop, but for the stack. So stack count, and we say slice, we take it from the stack, we append it, we append that, and I need to append the last thing as well, but got that. Okay, and maybe here it's an extra space just to make things look a bit nicer. So I think that's how we build this error. I'm just gonna leave it as a comment because it makes sense. And now we have to ds free, or I guess ds string builder free, or do I even need to build it? I don't think so. I think I only need to call this thing. I don't know what I pressed. I think I just need to call this thing and then say function parser, function position, and then we need to put here the result. So I'm gonna just do string builder to slice sb and then a slice, and let's have ds string slice. Right, so we can just generate the slice. This thing cannot return an error, obviously, so I can just say slice.len, slice.str. Oh shit. Oh really? That deletes more than... okay, so we just show the error, and then we can just ds free, and here I can just say, you know, sb.allocator and or I guess slice.allocator, just to free it. So this should show the error. Right, so if stack type checker is stack aq whatever, we are gonna put the context, we are gonna put the stack and returns. So if this thing is false, and I guess returns is on the func, on the cfunc, yeah, cfunc.rets. So if that's not true, we just type checker error stack not aq rets, again context function stack cfunc rets. What does it say here? Passing stfunc instead of stack st node. So I have to say name. And what do I do after showing an error? I guess I set the type checker to failed and continue. So yeah, so that should be kind of the beginning of our function type checking. Still to do there, but we still have some stuff to do. So for example, what if the types are generic? But let's start with this. Let's make, and let's main tests 0304. Wait, what? It's in examples. Okay. Examples 04 type check. So shit, what? We got okay, so I guess let's not import standard library yet. Let's just do it like that. So function main has non-matching return. It expected int but got nothing. Okay, let's add a 0. Now it worked. But what if we add another 0? Got int. It didn't. I don't like that. Not sure why it showed it like that. So if it's less than stack count, okay, let's make but got int. That's nice. Now at this point I need a plus, but why didn't it fail though? 1 second. Like it should fail in here, not implemented yet, right? Oh obviously I forgot to get the expression, like I forgot to get the expression. So let's do unreachable, get from the function body index j, we get the expression. So if we make, right, and we run it, it's not implemented yet. So we haven't done this case. So name is a function, we try to get it. So at this stage, a function can be missing. So we have to make sure that I guess if a function is missing, we cannot really do anything about this. So it's like, right, we don't know its type, so we should break from this for loop and also step the next function because we don't know what to do. So I'm gonna say here bool okay is equal to true, right? And here we need to stack context function get from the context. The name of the function is expression func whatever, expression expression name, it's a name, expression dot name dot value, and we need a stack context func I guess I can say cfunc. Yeah. It's a context func, but from the body somehow, right? Because I think cfunc body. Right, so let's think about it. Cfunc, okay. I mean, this could have been a function, but let's keep it like this for now. Why not? Like this could be a function like type check body, and it would just check if you know, functions exist. So yeah, but it's fine. So we have here a cfunc body. We try to get it, but this can fail. So if this thing fails, if it's not 0, it means that this function doesn't exist. So let's define an error for that. Function doesn't exist. Error func not exist. Function does not exist. So this is the error we need to show. I mean, it exists, but and we need to pass a node. That's interesting. We need to pass a node. Function does not exist. I guess the node is expression name, right? Function does not exist. And you know, type checker failed, and I guess okay is equal to false, and I can just break, right? Because I want I mean, I want to break from this for loop as well. Hmm. Yeah, I mean, whatever. Okay. So if we break, I mean, you know, if okay is false, here for example, if not okay, then we can just break from this for loop, right? And then again, if not okay, we can just break again. from, or I guess continue. It's ugly, but it should do the job. So if we don't find a function, it just shows that it didn't find a function. So that's what we should see. 127 1247. Really? The fuck? I mean, that literally cannot happen. Because, yeah, wait, what the fuck? Like, how could this one happen though? So we try to get, right? And we go context functions count. Oh my god, I forgot I is less than. Fuck. So it should say function plus does not exist. Alright, stdlib. I'm not really. Let's just add it as external. And let's try again. Function main has non-matching return. It expected int but got int. So we still don't do anything here. So let's say we found the function body, right? We have to assume that it works. So we need to take the last these arguments from the stack and make sure they are fine. So I have a function for that, kind of. Let me just copy it, and I'm gonna say type checker is stack matching function, or I guess args, and we give it the context, the stack, and the args, right? So here we want you know, obviously if the stack count is less than the args count, it's impossible. Then we have to go from the end of the stack, so stack.count -1, stack.count -1. I should be let's think about it. So args should be less than stack, that's for sure. So we want to go from, I mean, I could say like from stack count -1, but it's easier if I say from 0 to args.count, right? And then we have this stack slice and args slice. And what is the index? Because we are gonna have two different indices, one on the stack and one for the args. So args obviously is gonna be 0. That's easy enough, like I. But for the stack we need to add an offset. And what's that offset? I think it is, so let's imagine that the stack has 5 elements and the args has 2 elements, so it's 3 and 4. So it's I plus the counts with minus between them. So I plus stack count minus args count, right? So if we have the same number of items, it's I. If you have one more item on the stack, you have I plus 1, and so on. Okay, and we have to make sure that these two slices are equal, but not necessarily just equal. We'll see in the future that we actually want some more stuff. So here, let's do this stack match args, and we need args. So here, how are we gonna do the thing? Function as non-matching args, and then we can say expected, but got, and whatever. Function has non-matching args. And now I'm curious, it should be function meaning the stochastic node of the expression. Yeah, so it's like expression. Okay, so here let's replace this one with args. And then, so yeah, that's interesting. Has non-matching args expected, and we give it the args, and then in but got we should make a for loop. It's interesting. So we show the list of arguments, and then we go from 0 to stack count, but again there should be an offset here. But I think it's a bit different, because if the offset is negative, then it won't work. So I have to keep that in mind. Like if you have more arguments than stack items, then you have to show the stack as it is. So I'm gonna do here instead. So starting from stack count minus args count. Stack count minus args count. But again, if this one is negative, I actually want ds min, ds max between 0 and this difference. So let's say we have the same number of items, it's going to start from 0. You have one more stack, it starts from 1, and so on. I think that looks good. So this one is going to check for non-matching arguments. So if stack type check is stack match args, and we give it the context, the stack, and the arguments should be in cfunc body.args. I think it should be address or what? I don't remember. So if it's not, then we need to say type checker failed and stack type checker error match whatever. Show this, the expression name, the stack and cfunc args. And obviously we say okay is equal to false and break. So this is if the function call doesn't match. But what if it matches? Well, if it matches, we want to replace these arguments of the stack with the returns. Right, we want to replace them. So how am I gonna do that? Well, I guess just delete the last items and push the new ones, right? So I don't know if we have delete dynamic array. I mean, we have delete. We have pop, which pop I think it deletes the last item. Yeah. So we pop from the stack, and I'm gonna say null because I don't care. Right, so this one, it can fail. Right, it can fail. But it's like impossible to achieve that. So this unreachable. And how are we gonna do that? Well, make a for loop int I is equal to 0, I is less than cfunc body args dot count I plus plus. So we pop all of these, and then we have to append cfunc rets. We have to append the return values. So I guess I'm gonna do something like ds string slice like ret or something, and ds unreachable, yeah, whatever, cfunc. Right, we take the ith item from the return values. But I forgot to actually call the function. So we get the return value into ret, and we need to push it into array append. We need to push it into the stack. So stack and ret, and this is an spec ds error out of memory if it fails. Right, so that's how we modify the stack, right? We pop all of the items that were used as arguments, and then we push all the return values, or I guess all the return types. So if we check, it looks like now it works. 04 type check, right? Okay, but what if, let's say that we have something more complicated, right? So what if we go to stdlib and we take function dupe? What if we try to use dupe? Function dupe has non-matching args. Expected nothing but got nothing. Whoops. Okay. Let me try again with plus. I guess I fucked it in the so non-matching args. Type checker error stack match args. So we go from 0 to args count and we show the args, right? What? It should show the args of so it's stack and args. cfunc args. The fuck? Let me just panic with something here. Maybe also just add the number of cfunc args count because I'm not sure. 0. So I used the wrong function here. It's cfunc body. Alright, so expected int but got nothing, so that means something's wrong with what I print here. So the stack count should be 1. So the stack count should be 1. Let me just panic again. %d stack count. Like stack count should be 1. Am I right? Yeah, it's 1. Perfect. So we go here. We do max between. Oh, you know why? Because these are unsigned integers. So I should do instead is if this is smaller than args count, I'm using 0. Otherwise I do stack count minus args count. Alright, so it expected int but got int for the plus function. Func plus has non-matching args. Right. Um, 0 for example. So now what if I do dupe? It's gonna say expected a but got integer for dupe. So yeah, this is the part where it becomes a bit more interesting, because how are we gonna implement this stuff, right? How are we gonna do type checking with those kinds of arguments? I kind of want first to refactor this thing a bit because it's annoying to stack AST expression. So let's think. If I try to type check an expression, I need a stack. Let's have a function static int stack type checker check expression, and I need a type checker stack ast expression stack context. Right, so I want to copy paste this entire thing basically. or most of it into this new function, and let's see what we can do about it. So we have a C function, right? Which is just the expression. So it's more like expert func or something. All right, so let's try to fix this. We don't have the OK or this one. We just have return defer1. For that we need int result. Return result. So yeah, if this thing fails, whatever, so yeah. Stack type checker is stack match args, and this one, see, it needs the stack. Can stack be part of the context? No, not sure. Wouldn't make sense because my context has this stuff. So maybe I need this dynamic array stack. Right. There we do the thing, return default one. Check that. Here we pop all of the things from the stack. I would make it, maybe I would make it a reference. And it doesn't look like it matters if it's a reference or not, to be fair. Because the thing inside of it, it's already, but it would be nicer to have it as a reference. Wouldn't it make more sense? So this guy should take it as a reference. For instance, nah, it doesn't matter, right? Because pop, because we change. Oh, but I also changed the count. So I need it to be a reference. Right, and here. Why not? Just to make it simpler. So everything here comes as a, but I don't know why. So annoying. Okay, anyway. So we have all of this stuff, right? That just does check if it's expression fine, whatever. And now we can just replace this entire case with something like if not stack, or I guess if stack type checker check expression Here it's address of stack, here it's expression, here it's context. So if this thing is not 0, if this thing is not 0, then what do? We just set OK to false or whatever. So here it is, the expression. I already forgot what the expression was. It's address of expression. But here it's like we already know that expression is a name, so yeah, that's kind of I could just say name stack st node. Don't even care that it's a expression name, and then here we need expression dot name. Okay, so if that fails, we just set OK to false. So we want to break from this loop and then continue with the big loop. So yeah, I would also make a function like checking the expression body or something like that. So I check body of a function basically. So I could just copy this entire for loop because it's ugly as shit. Let's just say that we put it here. I don't need that because we're gonna just return stuff. Oh, and this should be after. Otherwise it sucks. So let's make it int result is 0 and here we defer. Okay, and now I can do stuff like this dynamic array body. But it's nicer to have the function, right? It's nicer to have the function. So maybe I can have stack stfunc. Here it's just stack. If it fails, it return defer 1. Otherwise, return defer 0. Right? It makes sense. That's just panic. Oh no. It just breaks here. Right, so it's like a for loop with j whatever, and we try to get the expression from the body. If it's number, we just push an integer. If it's a boolean, we just push a boolean. String, just push a string. If it's a name, we do the type check for name, and if this thing fails, we also fail the entire function body because we cannot do anything about it, so we just return. And if it's fine, then we just break the switch. So we go next. Okay, and if it's condition, we will implement it at some point. So let's just take this guy, and we should have something here like this. So we check the body, we put type checker, we put stack function and context. So if this thing is not 0, we just continue. Right? So if, because that's exactly what we do here, we type check the body. If the type check of the body fails, we continue, and then we do type check on the stack with the return type, right? So we should still have it work, right? But now the issue is we have these generic types, which is gonna be quite interesting. So when we do expression name, we type check that. First we check that the function exists, then we check if the stack matches the args, right? So there's the function dupe has non-matching args or what not. So wait, where's the, it should be here though. So we have is match args. If it's not matching the args, it can just fuck off. Okay, so how can we do that? So I would say that if you find an argument that's not in the context, it means it's generic, right? So let's have a function like this one for function get, but it's gonna be for data. So we come here, we say string slice name, and here it's data, right? So we iterate over the data, we have a data here, we get it from datas, and we compare it like that, and if it's fine, we just set it to data. So this is data get, right? So if we don't find, so if not stack type checker get data get, really type checker, wait, what? I thought it's type checker. Oh, it's context get. Okay. So if we cannot get, so here it's context, here it's stack slice, or I guess args slice, and then we need the result, right? We need the stack context data. So stack context data. So we just put data here. If this thing is false, it means generic argument. Right, so for generic argument, we have a bit of a different approach. Right, and if we have a non-generic argument, we just check like that. And I guess I'm stupid here, so Oh, but it's only the false case, so I'm just gonna leave it. Right, so I mean it is the else if case. Right, so if we have a generic argument, we need some kind of mapping from the input to the output, right? Because if the function takes in an a and outputs an a at some point, the a that is being outputted should be the same as stack slice. So we need to change that. We need to change that. We need to change the a's to a type. But then it's gonna be even more fucked up, because it's like, what if you have generic type as input and generic type, like what if you have on the stack already an a? That's gonna be interesting. That's gonna be really interesting. So how can we do the DS panic? Not yet there. All right, so if it's gonna panic, no, really, has non-matching arguments, really though. Oh, this one is with an error, not true. So if it's not 0, and I forgot to make, right? Yeah, not yet. So we don't have generic arguments yet. Okay, so how can we have these generic arguments? Well, for this case that we have right now, we can have another if. Let's check that the stack slice exists. So, oops. Let's call this one args data and stack data. Not really important because we won't really use them. But yeah, so oops, if both of them are generic, then not implemented yet. But only one of them is generic, maybe it's a bit easier, right? So in case, oh, and then there is another case, but let's take this one first, right? When the argument is some generic kind and the stack also is the generic kind, then we don't really know yet what to show. But if the stack is not generic, then we can just infer that this type should be the same as this one, right? So how can we do that? We can infer that. Right, I would say that we need some kind of another context. It's kind of complicated, to be honest. Because you can have things like rotate, or I don't know. I mean, we don't really have that kind of complicated things. Like imagine you had like a function, I don't know, some name, and then you have ABA. Like you need to have the same type for this argument and this argument. And I don't know, it returns some AB. I mean, this one is just pop, but with extra steps. So, right, it's really weird because we need to map A, and we say, okay, A is gonna be this this type in this context. So we need the function context. We need some kind of function context that we create here, and then we also use it for the returns. So it needs to be input and output. So it needs to be in this thing, cfunc. What can that thing be? Or how can we use it, at least for this case? Because this one is the easiest, I would say. I can have a mapping from the arg slice to the stack slice. Right, I can have a mapping like that. Man, it's kind of really complicated, to be honest. Need more space. Yeah, like it's really weird. But again, like the inference only happens for a single expression, like for a single name at a time. So it doesn't matter if you reuse the a later on in another function. That function is unrelated to this one. So that's why I think the context should only be part of this this right here. So right, it should only be a mapping from or it's like a list of two items, so like a tuple. Right, it's a list of tuples. It's like a list of tuples. And we have the name of the argument, or I guess the type of the argument, and the type that it's converted into, like it converges into that type. Right, so let's have type def struct ds tuple. Maybe we'll add it to ds. That's what I'm thinking. So it's gonna be void pointer first, void pointer second. I don't like that. Then I guess stack context function, and we just make we just make here a type def struct ds string slice key ds string slice value what should be the name, string slice map, string slice kv. So I'm gonna say that we need a dynamic array of string slice map oh, and I forgot about the can't do that. Okay, so I have string slice kv. Right, maybe it's a static int string slice kv get, and we give it the ds dynamic array da and string slice key, and we expect the value back, pointer value. So let's have a for loop the same as we do in this one. Right, and we just go over the a, we check if it's equal to key, and we set value dot oh, I guess this one should be string slice kv. Here it's key and here it's value. Okay, so that's how we get string slice kv. So here, for example, we already have string slice map. String slice map. We need some kind of key and the pointer to value, or like reference to value. Right, and if this thing is not equal to 0, it means a new generic, so we have to give it we have to, you know, give it a type, and else it means that we actually found a generic with a given type. So we have to check if same type. So if it's a new generic, but let's first figure out what is the key. So the key should be args slice, and we are gonna have a ds string slice value, and we pass it here value. Okay, whatever this one wants a pointer, let's just give it the pointer. Okay, so if it's a new generic, it means we don't have anything in value. Right. So we need to append, like at this stage we just need to append types into the slice map. So ds expect ds dynamic array append string slice map, and here we need to say string slice kv, key is equal to args slice and value is equal to stack slice, right? ds error out of memory. So it's like, I guess also others of this thing, but yeah. So we map the current generic argument to the current argument from the stack. So if we check out 0 for type check, let's just say dupe has the argument a, and on the stack we have an int. So we map a to an int. So now when we get to the return, we know that this a should be an integer, right? So that's what we know. So basically when we put our stuff, we put our load on the stack, instead of putting a's, we put integers, right? So that's the idea. And if we have already something, let's just say not implemented yet, and we'll implement once we get to needing this. But yeah, so the idea here, if we have an a as an argument of a function and we have some kind of other type on the stack, we just put that as the mapping. So now our mapping should have that right here. So let's go here, and this needs a dynamic array. This dynamic array. Oh, how is it called? Let me just copy it. String slice map. Shit. So I'm gonna put string slice map. So we can just dynamic array init string slice map with the size of string slice kv. Cannot fail, so that's nice. And here we can say address of string slice map. Alright, so we have the string slice map, and instead of directly appending stuff, we have to check some things. So similarly to this check right here, similar to this check, in context we try to get the ret, and we'll have like a data here, which is just stack context data, stack context data is equal to 0. Right. So if we don't find the item, we do something, and if we actually find it, then we just ignore everything and just append the type. But if we don't find the type, it means it's generic, so we have to do this thing with string slice map. So how did I call that functions? Stack string, shit, already forgot. String slice, yeah, string slice kv. So we have to do string slice key value get. The key is gonna be ret, and the value is a string slice. So this string slice value is 0, and this thing wants pointer, yeah, whatever. So if the type doesn't exist, then that's kind of it kind of sucks, right? But if it exists, so if it's, no, if it doesn't exist, so that's the first case, actually. So here it's not exist. Yeah, so if it doesn't exist, then I guess we just put it on the stack. It's like we haven't inferred what type it is yet, so we cannot really say what we can do with it. So we just put it on the stack like it is. But if we actually have a type, instead of red we put value. So let's try to remake it. 1372. 1372. How did we get here? Okay, so we tried to get a data from the args. Wait, excuse me? I don't think this should happen. So does it happen? No. Does this one happen? No, what? Then how is this? Whoa, what? 1 second. So in here we have 0, then we call to dupe. So what the fuck? Wait. So this is gonna be called for dupe. So if I show %s name.value .plan and name.value .str, we should see dupe, right? So we call to dupe. Dupe has an a and stack has an int, right? So let's think about it. This thing should work fine because it's defined, but then we have this stack match arguments, which I think should be fine as well. So if I do for unsigned I0, I is less than string slice map dot count I plus plus string slice kv. Let's try to print what we have in the slice map because that's a good point. Do we have this login form? Like I would expect to see a int. So a is mapped to int, right? So kv keylen kv key dot value and kv value len kv value str. Oh, str. Right. So that's what I expect to see here, and then ds panic whatever just stop. Right, so I expect to see that we mapped. Oh shit. So it's inside of match args 1372. Ah, this is match args, okay. So but why does it get in that position? So match args, right? Match args. So stack is gonna have an int on the stack, and cfunc body args is Okay, let me just ds log info percentage s args slice len args slice str, and let me do the same for stack slice. Let's see what a and int. Oh, I haven't defined the int data type. So let's do data int extern. One five seven. So it mapped, right, the a to integer as expected. So if we make, it type checked, right? So it type checked. It produced int, and then that's it. But what if I say that we have three a's in here? Like, just imagine that that's what type checking does. Func main has non-matching return, expected int, but got int. So it still works, right? And what if this was a b? Func plus has non-matching args. It expected int, but got int b. Right, this one looks good. Huh. Not sure how I feel about it, but what I'm curious, what if we import stdlib now? How many errors are we gonna have? Not implemented yet. 1372. 372. So it happens. Let's put this back because I'm curious where exactly, like in which function this happens, but I cannot really see that. But maybe we can figure it out by the name of the, so AA. That's interesting. Okay, what function can that be in stdlib? AA. So could be rot. Like it's a lot of functions that do stuff like that. Right, so maybe you can just ds log info. Let's see the name len name value, len name value. I'm curious which function that is. I mean, it looks like it's the first one, so it's rot. It's rot. How the fuck can it be rot? Oh, so it's rot here, I guess. So, oh yeah, so we have a on the stack, right? And basically we said that the rot works like this, a, so it's matching. So what can we do if both of them are undefined? I'm gonna say that, what if both of them are generic types? I think I'm gonna say that we just append that to the slice map, right? We just append that to the slice map. I don't see what else you can do about it. So if you have a maps to, no, fuck. I guess, yeah, if you have an A on the stack, then you say, and you have another A in your function, you have to say that your argument maps to that. Right. I think it makes sense. Let's check what happens if we do that. So it passes through them, right? It even goes to swap, which is in another place. So here it type checks, right? It type checks because A is matching to A. Not sure if it's actually, working properly though. Because we don't check if they are equal. We just say, okay, if it's not a type, and the other thing is also not a type, we just map them. Because if you think about it, this can be like XYZ here. It doesn't matter what types you put. But it matters for the output. Right? So if I put here an A, is it gonna fail? Yeah, it's gonna fail because it's gonna say function rot prime has non-matching return. Expected CAA but got CAB. Yo, it's actually working. What the fuck? Yo, it's actually working. And then 1629. Same. Oh, so for if statements, I don't do something. Okay. Okay, it makes sense, but it looks like we are actually type checking stuff in this expression. Right? So it's like match args, but we still don't have this one yet. So yeah, if you have two types that are generic, you just map from one to the other. And if the type from the stack is actual type, if the type on the stack is an actual type, then does it even matter if it's an actual type or not? Shouldn't we just be able to make this mapping regardless? Shouldn't we just be able to make this mapping and it's gonna work? So let's say you have a type which is int, or like a function that gets an int as an input. Let's think a bit. So let's say A is generic, and this one is also generic. But what if this one is int? You need to check if A is already mapped to int. If it's not already mapped to int, you add that mapping. Right? But if it's not already mapped, but if it's already mapped, you have to do what? What do we have to do if it's already mapped? If it's already mapped, right? So if it's already mapped, what do we have to do? I don't think you have to do anything if it's already so. I guess, yeah, we don't even need this else statement. I think it's enough to just do this, and without the if statement, obviously. So it's like if the argument of a function is generic, then you can just check the mapping. If you have if you don't have a mapping yet, you just create a new one. But if you have a mapping, what do you have to do? If you have a mapping, I think you need to check that the value is equal to stack slice. I think that's what you have to do. You have to make this kind of check. Else, if stack slice is not equal to value, then we return false. Right, so it's like we have a, b, c on the in the function arguments, and we have int, boolean, string on the stack, right? They are all defined. But what if, so let's go to 0, 4. Let's make and let's rerun just to make sure that that worked. 1, 6, 2, 3. Okay, so what if we have a function f that takes in a, b, c, and I don't know, doesn't return anything. It just does pop 3 times. And we have 0, some string, and true, and we call f, and then we put a 0 to make sure, right? Ah shit, it's because of stdlib. Let's just remove all the stuff that has ifs. Like from here below. Right, let's just remove all of that. So we only have these, wait, where is, yeah, pop. Okay, so we only have these external functions basically, right? So if we run it, it works. But what if we say that this one should also be the same type as a? It's gonna say expected ABA, but got int string boolean, right? And if here we put a 1, it's gonna work. Holy shit, this is so cool actually, right? So that's the actual check that we need to do. Nice. So it's much better. It's much better. But there's also the case, what happens if the stack has the type A? No idea. If you have an A on the stack, I'm not sure what you have to do. Right, like I could add an else if here. Like what happens if you have a stack slice and you don't have it? Well, yes, panic. I don't know. I just put that on. Or what? Wait, what the fuck did I do? I guess I forgot. Yeah, it looks so weird, but it still works. Nice, but I'm not sure what you have to do in this case. Not implemented yet, right? But we saw that if statements are not done yet, but it somehow looks like this thing is kind of done. So let's say this thing returns a C. What is this thing gonna complain about? Expected C but got nothing. That's nice. So if we don't do a pop, oh nice, expected C but got A because we pop C and B. But what if we rotate counterclockwise first? It works. Shit. Oh shit, it's actually really good now because we have type checking and it's actually working, kind of, right? It's actually kind of working, which is pretty awesome. So yeah, I'd say, you know, the next steps would be to, so looks like the expression name is kind of completed. Not sure if I missed anything, but we'll see. It's only that case I'm not sure about yet because we haven't encountered it. So which one was it? Damn, I'm lost. It's here. When we try to match and the stack contains something weird, I'm not sure what to do with that. But other than that, we match kind of everything. Right, we kind of match everything and we show all the errors properly. So the last thing we have to do is implement the if statement. And again, for the if statement, I'm just gonna do same outputs and inputs, so you cannot have you know, weird branches. But yeah, I'm pretty happy with the result. So it works with generic types, and that's because we consider everything to be a generic type though. So yeah, which is fair. So yeah, the inference kind of works. That's pretty cool. Obviously it's not gonna work with memory right now, I think. I don't know, I don't think so. So yeah, but you know, here it's not gonna work if you say int, for example. I think this is the undefined case. No, right, like it doesn't make sense to put an integer here unless you do like, I don't know, pop 0, right? That's gonna work. So yeah, I have to figure out what's that edge case that I just put a comment for. So yeah, but it's kind of working, right? Is it gonna work on hello world? Yeah. Is it gonna work on fizzbuzz? Not really, because we remove these functions for now because we have to implement if statements. So yeah, I mean, type checking started to work, right? So if we make mistakes, it's gonna warn us about them, and yeah, that's pretty good, I would say. So yeah, I guess that's all for today, and we'll see next time when we implement the type checking for the if statements. So see you next time.